In the mid-1930s, British fighter aviation, like much of Europe's, was in a dire state. We won't dwell on the reasons for this, but the fact remains. By 1935, the backbone of the Royal Air Force consisted of obsolete biplanes armed with little more than rifle-caliber machine guns. After the end of World War I, successive governments were extremely reluctant to spend money on new weaponry. On top of that, the economic crisis that gripped the West in the late 1920s and early 1930s really took its toll. By the time the threat from Nazi Germany became real, there was catastrophically little time left to create modern fighters. Luckily for England, some aircraft designers didn't limit themselves to the tight restrictions and stingy funding from the Air Ministry, and pushed ahead with their own developments. That is exactly how the legendary Supermarine Spitfire, designed by Reginald Joseph Mitchell, came into the world. Along with the Hawker Hurricane fighter, this aircraft bore the brunt of the fighting during the Battle of Britain. Furthermore, the United Kingdom had a powerful scientific and industrial potential, which allowed them to develop new planes in a very short time and, most importantly, perfect them right in the heat of combat. Facing the German threat in 1934, England's aviation policy changed drastically. The government adopted a program that called for not only the rearmament of the entire military aviation branch, but also a massive expansion and modernization of the industry. The financial hardships of the 1920s and 1930s were forgotten. Money started flowing like a river, and the development of a huge number of new aircraft began. By 1935, 41 specifications had been issued, a record number since 1923. Admittedly, part of this dealt with the serial production of finished aircraft such as the Hawker Demon, Fury, and Gloucester Gladiator fighters. Another task under the code F-3535 envisioned creating a new high-speed monoplane that could serve as a base for a future fighter. Although several original designs were presented at the competition, none of them ever went into production. But the most interesting thing for us is a group of 4 specifications for a modern fighter that was supposed to receive the most powerful armament ever considered in England. The possibility of mass bomber raids on London and other British cities really worried the leadership of the Royal Air Force. They remembered the attacks by German airships well, but since then, technology had taken a huge step forward. Fighter Command, which was responsible for the country's air defense, was particularly concerned by the fact that a potential enemy's bombers were becoming increasingly well protected. They were receiving tough armor and serious defensive weaponry. Because of this, the weapons on the most modern English fighters at the time, the Spitfire and Hurricane, which consisted of 8 .303 caliber machine guns, could turn out to be simply ineffective against them. Studies showed that fighter efficiency could be improved in 2 ways, either by increasing the caliber or by concentrating firepower. 2 of the mentioned specifications called for the creation of 2-seat fighters for the Air Force and the Navy. Their defining feature was supposed to be 4 heavy machine guns mounted in a hydraulically operated turret that rotated a full 360 degrees. It was thanks to this requirement that the Bolton, Paul Defiant, and Blackburn Rock fighters appeared. The 3rd requirement concerned the development of a single-seat fighter armed with 8 Browning machine guns. But the 4th specification, under the code F-3735, became perhaps the most unusual and revolutionary in the history of British aviation. It envisioned the creation of a single-seat, single-engine aircraft capable of operating day and night. It was supposed to reach a speed of 330 miles per hour at an altitude of 15,000 feet. But the main attraction, of course, was the armament, the most powerful ever installed on a fighter, not just in Britain, but in the world. This was a battery of 4 cannons of 20 or 23 millimeter caliber, intended to guarantee the immediate destruction of the target. In Air Ministry documents, this project was simply called the Cannon Fighter. Today, we would call such an aircraft a point defense interceptor. Its main task was to deliver its firepower to the designated point as quickly as possible, meaning close to enemy bombers, and strike. Therefore, the designers were not required to make this plane maneuverable for aerial duels or capable of staying in the sky for a long time. Nor was this aircraft intended for attacks on ground targets. The Royal Air Force Command pinned high hopes on the F-3735 project, but on paper, everything looked much simpler than in reality. Apart from the purely engineering challenges that faced the designers, a serious problem arose with the armament. It became a real headache for the Air Ministry. The thing is, as of 1935, Britain simply did not have its own aircraft cannons of 20 or 23 millimeter caliber. They had to look for suitable options across the English Channel. In 1936, Major Thompson and Captain Adams from the ministry's technical department visited the Hispano Suiza plant near Paris. They arrived to attend a demonstration of the firm's newest development, the 20mm Type 404 cannon. This weapon was the last word in aviation armament technology and had already been selected by France for installation on their newest fighter, the Marine MS-406C1. The muzzle velocity of the projectile was 2,820 feet per second, which made the Type 404 the most effective cannon of the required caliber. So the Royal Air Force decided to adopt it for service. But manufacturing difficulties popped up right away. At that time, the British government demanded that all weaponry be manufactured directly within the country and not depend on support from other nations. The two main British arms firms, Vickers and Birmingham Small Arms, were completely loaded down with the rearmament program. On top of that, it is hardly likely Hispano Suiza would have agreed to hand over a license to their sworn competitors. To get around these obstacles, they found a pretty simple solution. An enterprise was registered on English territory with a long and solid-sounding name, the British Manufacturing and Research Company. In reality, though, it was neither British nor research. It was a subsidiary unit of Hispano Suiza, created exclusively for the production of the Type 404 cannon, which got the new name British Hispano. So the weapon was found. There remained just a minor detail, creating an aircraft for it. The appearance of specification F-37-35 caused a real stir among British aviation builders. Entering the race were recognized giants, Hawker, Supermarine, Bristol, and Boulton Paul, as well as companies less well known at that time, Westland, General Aircraft, and Airspeed. During the development process, it became obvious that creating a fighter with powerful armament and high combat characteristics was no easy task. The most acute problem became the engine. It seemed to many engineers that the power of a single motor simply would not be enough. Therefore, at their request, the Air Ministry revised the conditions and allowed twin-engine aircraft to participate in the competition. Some firms tried to go down the path of bold experiments. For example, the Airspeed AS-31 project proposed a single-engine layout where the pilot's cockpit was located on the leading edge of the stabilizer, and the General Aircraft Company planned to use a wing that could change its area. The Bristol Type 151 project was less radical, but really ambitious. Initially, the designers figured they could hit a top speed of 440 miles per hour. They planned to achieve that number thanks to the powerful new Hercules engine and an extremely high wing loading for the time, 33 pounds per square foot. However, detailed calculations showed that the takeoff and landing performance of a design like that just wouldn't cut it. They had to lower the wing loading, and in that configuration, the fighter could only reach 357 miles per hour at an altitude of 2,500 feet. As an alternative, Bristol also proposed a version with two Aquila AE-3S engines mounted in nacelles under the wings. The firms Boulton Paul and Hawker proposed classic single-engine monoplanes. But Reginald Mitchell, over at Supermarine, submitted two designs for the competition simultaneously: the Type 312 with a single Merlin engine and the Type 313 with two Goshawk engines. For the latter, they planned to use an evaporative cooling system similar to the one the Germans used on the HE-100 fighter. But surprisingly enough, the competition was won by the P9 project from Westland, which at first glance didn't seem to feature any particular innovations. The Westland Company came into existence back in 1915. Originally, it was just a subsidiary of Petters Limited, a firm that manufactured gasoline engines. Their main job was building aircraft for the Royal Air Force. At first, they assembled planes under license from other companies, but eventually they established their own design bureau. In 1935, just a few months before the requirements for specification F-37-35 were released, Westland became an independent company. Now it was called Westland Aircraft Limited. The firm was based in the town of Yeovil in Somerset. Sir Ernest Petter ran the whole operation, and the chief designer was his son, William Teddy Petter. Without a doubt, William Edward Willoughby Petter was a very talented engineer. It is enough to mention that already after the war, while working at the English Electric Company, he had a hand in creating such famous aircraft as the Canberra Bomber and the Lightning Fighter. But at that moment, his only asset was the auxiliary army plane Lysander, which was being mass-produced. It is worth noting that Westland had almost no experience in building fighters. In 1931, they released a prototype fighter under specification F-730. It was a biplane with 4 machine guns, but it did not show any outstanding flight characteristics. In addition, they designed and built a mock-up of a fighter for assignment F-3535. However, the Air Ministry rejected the project, stating that the firm simply did not have the experience to create such combat aircraft. In early 1936, as soon as the aviation industry received the detailed requirements of specification F-3735, William Petter sketched the first outlines of the future aircraft. Truth be told, the word sketched is more of a metaphor here. Colleagues joked that it would be hard to find a worse draftsman in the world than Petter. Therefore, under the leadership of Teddy, all the graphic work was performed by Dan Adkins, and the calculations were handled by Fred Digby. As a result, the team presented the military with a project for an elegant twin-engine monoplane. As the heart of the aircraft, Petter chose the Peregrine engine from Rolls-Royce. It was an improved version of the Kestrel motor with a new supercharger and other modifications for better performance at medium and high altitudes. The engineers calculated that with a power of 885 horsepower, the fighter would be able to accelerate to 398 miles per hour, although the Peregrine engine itself was still at the development stage at that time. To cut down on drag, the cooling radiators were tucked right inside the wing, between the fuselage and the engines. To ensure easy takeoffs and landings, they planned to fit the wing with Fowler flaps and automatic slats. Up in the nose, they installed 4 20mm British Hispano cannons. This setup offered some serious advantages compared to mounting the weapons in the wings. First off, it made aiming a whole lot easier, and second, it allowed the wing to be made thinner. On top of that, it simplified heating the cannons, and the weight was concentrated closer to the center, which improved maneuverability. Although for a twin-engine aircraft with heavy engines out on the wings, that last factor wasn't exactly a deal-breaker. The aircraft's tail originally featured twin fins positioned at the tips of a low horizontal stabilizer. It was in this configuration that the P9 project won the F-3735 competition, and in January 1937, Westland received an order for 2 prototypes. But even before construction began, as is often the case, the design had to be tweaked. Wind tunnel tests on the P9 model revealed a problem. When the flaps were deployed for landing, the tail got caught in a zone of severe turbulence. So the twin tail idea was scrapped. Instead, they installed a single large vertical fin, and the stabilizer was raised high up. Assembly of the first prototype began back in May 1937, but production immediately started falling behind schedule. The sheer number of technical innovations in the aircraft's design, combined with a lack of necessary experience among the Westland engineers, really took a toll. It wasn't until October 1938 that the first P9 prototype finally rolled out of the assembly hall in Yeovil. It was an all-metal, twin-engine aircraft with a low wing configuration and very elegant lines. Designer William Petter had packed it with a host of innovations that hadn't been seen on fighters before, at least not on British ones. For instance, the fuselage skin was made of magnesium alloys for the very first time. This provided better strength at a lower weight compared to standard aluminum. They managed to get a relatively thin wing profile thanks to the use of special structural beams, spars which were manufactured by stamping followed by machining. The rectangular center section of the wing was held up by 3 of these beams, the main one which ran straight through the fuselage, and 2 auxiliary ones, front and rear. The outer wing sections had 2 beams each. An important structural element was the armored bulkhead inside the fuselage. The front wing spars were attached to it, and this is exactly where the mounting points for the cannon rack were located. The design of the fuel tanks was truly unique for that time. Today, we would call the solution integral, because the tanks were actually part of the wing's structural framework. Each of them consisted of 2 sections separated by the main spar, and the ribs acted as the internal partitions. The outer layer was made of duralumin with a protective layer of Dynatex rubber underneath that was 0.2 inches thick. The total weight of this system was 316 pounds and it held 134 gallons of fuel. Plus, any section could be easily removed for repair or replacement. Designer William Petter chose this complex layout for a reason. He aimed to make the aircraft as dense, lightweight, and compact as possible. For better aerodynamics, the entire skin of the wing and fuselage was attached using flush rivets. Another interesting engineering solution concerned the engines. The rear part of the engine nacelle was a single unit with the flaps, and when the mechanism was activated, it extended backward and downward along with them. They mounted a powerful armament of 4 British Hispano Mark I cannons in pairs on a special tubular frame. The top pair was staggered back a little, so the whole structure formed a single combat module. It was attached to the armored bulkhead and covered by the nose cone. The ammunition drums received extra armor protection, and the spent casings didn't just fly all over the place. Instead, they were collected in a special bay under the center section. You could also mount a G42B gun camera right next to it. The main and tail landing gear struts were equipped with Dunlop wheels and retracted aft using hydraulics from Dowty. The operating pressure in the system was 500 pounds per square inch. That pressure was generated by just one pump mounted on the right engine, since redundancy for vital systems hadn't really come into fashion yet. The hydraulics were responsible for extending and retracting the landing gear, operating the flaps, slats, radiator, brakes, and even the weapon controls. That last point only applied to the prototypes and the first 4 aircraft of the series. Later on, they added a pneumatic system to the fighter with a working pressure of 1,200 pounds per square inch, which also served as an emergency backup for lowering the landing gear and flaps. The flight control system consisted of tubular push-pull rods. The aileron trims had to be set on the ground, but the pilot could adjust the elevator and rudder trims directly in flight. The operation of the wing mechanization was synchronized. Even with the slightest extension of the Fowler flaps, the radiator shutters opened completely. This gave the engine the maximum airflow needed for startup, taxiing, and takeoff. And when the flaps extended to a quarter of their travel, the slats would automatically slide out. Another revolutionary detail used for the first time on English fighters was the teardrop canopy. It provided the pilot with excellent 360-degree visibility. Later on, this design became the standard. Just remember the Typhoon, Tempest, or Spitfire Mark IX. But at that moment, it was a real technical breakthrough. After the final checks were completed, the P9 prototype was transported to the testing center at Boscombe Down under the strictest secrecy. It is worth noting that this project was kept under wraps for a very long time. Even in the authoritative Jane's reference book from 1941, when the fighter was actually already in service, only a single photo was published, and the technical specifications started with the phrase, "according to enemy data." As previously mentioned, the Peregrine engine was still in the development phase back then. In fact, the aircraft was fitted with just the 4th and 7th examples of this motor ever produced. They caused quite a headache for the Westland engineers and the Air Force mechanics with their constant malfunctions, which seriously delayed the start of flight testing. Finally, on 11th October 1938, the new fighter took to the skies for the first time. Company Chief Pilot Harold Penrose was at the controls. According to him, that first flight turned out to be completely unplanned. After a few taxi runs down the strip, he had to stop because the engine started steaming. During the third attempt, when the pilot applied the throttle, the aircraft accelerated a little too much. The natural slope of the airfield contributed to this, and there was a very real danger of running off the end of the runway. So the pilot went to full throttle, and the aircraft lifted off just 500 feet from the airfield fence, giving the manufacturer's observers and the Air Force representatives quite a scare. During that first flight, which lasted 30 minutes, test pilot Harold Penrose noted that the fighter's flight characteristics generally matched the calculations, although it was not without its flaws. For example, the rudder did not respond at all to inputs within 5 degrees, and the pilot had to use significant force to move it to a larger angle. Subsequent testing revealed a number of other issues. During steep turns, the tail of the aircraft would start to shake violently. Later, they figured out that this was caused by airflow interference between the vertical fin and the stabilizer. At high speeds, the P9 had a noticeable habit of dropping its nose, and when the speed dropped almost to a stall, the automatic slats engaged way too sharply. The raw engines also made themselves known. The main problems involved overheating and an imperfect fuel system. Now, these teething troubles weren't critical in themselves, but the Rolls-Royce company had focused almost all its resources on improving their main engine, the Merlin. Perfecting the Peregrine engines was viewed as a secondary task, so things moved very slowly. During testing, the prototype's unusual exhaust system caused plenty of headaches. On both sides of each engine, deep under the wing skin, pipes ran all the way to the trailing edge to vent gases. Although this reduced air resistance, the fire risk was just too high, as confirmed by one of the test flights. That was when an external exhaust pipe burned through, damaged the aileron linkage, and caused it to jam. It was a stroke of luck that the fire didn't touch the fuel tank, otherwise the consequences would have been much worse. After this incident, the designers went back to the classic layout with standard exhaust stacks. The Air Ministry was waiting impatiently for pilots to test the new fighter, which by then had already been named the Whirlwind. Finally, when the Westland engineers had sorted out the control system, the aircraft was ferried to Farnborough on the last day of 1938. There, 4 Royal Air Force pilots joined the trials. Despite a number of remarks, the Whirlwind's flight characteristics were generally recognized as meeting the requirements of specification F-3735. It was time to launch the plane into serial production. Of course, given the tense situation in Europe, it would have been logical to start preparing for serial production even before the prototype tests began. However, the Air Ministry evidently doubted that the Westland firm was capable of creating something truly worthwhile, so they decided to wait for objective results. Because of this, the order for the first batch of 200 aircraft didn't come through until late January 1939. Later that same year, another order for the same number of fighters was placed. The company told the customers that the first production aircraft would be ready 9 months after work began. Meanwhile, the second Whirlwind prototype arrived for testing. It was fitted with Rolls-Royce Peregrine engines. It differed from its predecessor by having a larger rudder. On top of that, to eliminate tail buffeting at high speeds, they installed a special fairing at the junction of the stabilizers. Just like the first prototype, this aircraft didn't have any armament at first. That was installed later. The plane's maiden flight took place in March 1939. Reports from the Royal Air Force showed that the aircraft was pleasant to fly, although there were some difficulties. At high speeds, the controls became heavy, and at low speeds, the elevator wasn't effective enough, making it hard for pilots to pull off a 3-point landing. The trials also revealed that the leading edge slats performed poorly, so on the production models, they decided to just lock them in the closed position. In May 1939, the latest aviation technology was presented to a delegation of British members of Parliament. Among the exhibits was a Spitfire F Mark I with a variable pitch propeller. But the show was stolen by another aircraft, the second prototype P9. It was introduced as a secret twin-engine fighter, and it streaked right over the heads of the spectators. After the flight trials wrapped up, the fates of these 2 experimental aircraft diverged. One of them was used to test various armament setups, for instance, 4 20mm cannons mounted in a row, which gave the plane its characteristic chin, or a single powerful 37mm cannon for hunting ships. They even tested a battery of 12 Browning machine guns. The first prototype was written off at the end of 1942. The second one had much worse luck. It was sent to the scrapyard on 11 June 1941, even though it had spent only 98 hours in the sky. The first production Whirlwind took to the air in June 1940. That was 17 months after preparations for production kicked off, not the 9 months Westland had promised the Air Ministry. You can pin that serious delay on 3 main reasons. First off, the ministry refused to gear up for production while the prototypes were still being tested. Second, Rolls-Royce just didn't devote enough attention to working out the bugs in the Peregrine engine. And third, Westland itself was simply short on engineers, which made it impossible to rapidly implement changes to the aircraft's design or assembly process. Because of all that, a staggering 4 years and 4 months passed between the initial order and the flight of the first production model, an unheard-of timeline for that era. That makes the advanced engineering solutions built into the Whirlwind look even more impressive. They allowed it to remain a thoroughly modern fighter when it finally rolled out, while plenty of other designs were becoming obsolete before they even left the drawing board. So, production got underway, and RAF Command started figuring out exactly how to deploy this new bird. Initially, the plan was for the Whirlwind to serve as a night fighter. The first unit scheduled to receive the new planes was Number 25 Squadron, a night fighter unit. At the time, they were busy testing Bristol Blenheim Mark Is equipped with the first British airborne radar, known as AI. On 30 May 1940, the second prototype flew from the Boscombe Down Testing Center to North Weald, where Number 25 Squadron was stationed. Just 2 days later, the squadron leader, Kenneth McEwen, took it up for a test flight. During the first weeks of June, the first 2 production airframes arrived at the base. However, by the end of the month, the situation in Europe had taken a sharp turn for the worse, forcing the Air Ministry to urgently change its plans. France had surrendered, leaving England to stand alone against the Nazis. As early as July 10, 1940, German aircraft began attacking ships in the English Channel. This was the preparation for Operation Sea Lion, which called for the landing of 20 divisions on the British Isles. Hitler issued the order to completely destroy the British Air Force. Thus began the legendary aerial confrontation known in history as the Battle of Britain. The commander of the Royal Air Force, Sir Hugh Dowding, faced a very difficult task. Some of his squadrons were severely depleted by fighting in the skies over Norway and France, while others, conversely, had absolutely no combat experience. They were up against experienced German aces who had gained their initial skills back in Spain and cemented them during the war in Europe. With his small forces, Hugh Dowding had to hold back the well-trained Luftwaffe juggernaut. He had to provide air cover for British industrial centers, airfields, radar stations, and other vital targets. This list also included Royal Navy bases. As Hugh Dowding himself wrote, "I have no other desire than to give all possible support and protection to the fleet, because if we lose command of the sea, we lose the war whether the invasion takes place or not." Aside from the threat of air raids, there was also the danger of a German troop landing. And here, the Whirlwind aircraft could prove to be simply indispensable. At that time, it was the only mass-produced British fighter capable of effectively striking enemy landing craft and armored vehicles. Evidently, that is why the head of Fighter Command decided to equip No. 263 Squadron of day fighters with Whirlwinds and use it to defend the fleet bases in Scotland. When this decision was made, No. 263 Squadron was reforming in the Scottish town of Drem. After heavy losses in the battles over Norway, where the pilots flew Gloucester Gladiator biplanes, the unit was being re-equipped with Hurricane fighters. Harry Eales was appointed as the new commander, and on July 7, 1940, he personally ferried the first Whirlwind to the base. Since deliveries of the new fighters were held up due to teething troubles with the Peregrine engines, the squadron decided to keep their Hurricanes in service as well. This was necessary so the pilots wouldn't lose their flying proficiency. At first, the Whirlwinds trickled into the unit very slowly, so combat readiness remained low. The fleet roster shifted like this. At the end of July 1940, they had 14 Hurricanes and 3 Whirlwinds on hand. By August 17th, there were 13 Hurricanes and 5 Whirlwinds, although all 5 of the new aircraft were grounded and not ready for a fight. On September 14th, the record showed 12 old and 7 new planes, with only 4 of them actually combat-ready. This situation with the new fighters developed because of the Battle of Britain, which was in full swing at the time. Circumstances demanded that they rush the aircraft to the squadron as fast as possible. Because of this rush, they didn't have time to incorporate all the necessary modifications to improve flight characteristics into the first 9 production airframes. The Westland Company clearly lacked the resources for rapid modifications, so the planes in this batch even differed from one another. The Peregrine engines also turned out to be very temperamental under combat conditions. On top of that, since both of the aircraft's propellers rotated in the same direction, it created a severe torque that made taxiing difficult. If the pilot lost focus for even a second, the fighter would try to spin around on its own. Naturally, this annoyed the pilots and gave the mechanics plenty of headaches. Despite all the shortcomings, the process of mastering the new equipment went on, and the 263rd Squadron's first losses actually happened in Hurricanes. On July 13, 1940, one of these planes crashed while heading back to the airfield after a failed intercept of an enemy bomber. Fortunately, the pilot survived. But just later, on July 20th, a crash involving another Hurricane resulted in the death of the pilot. Then, on July 31st, while returning from a night patrol, the squadron leader's plane wrecked during the landing. Harry Eales himself was not hurt. They lost the first Whirlwind on August 7th. A tire blew out during takeoff, damaging the landing gear. The pilot managed to get the plane into the air, but under orders from the ground, he successfully bailed out. Up until October 1940, the 263rd Squadron kept on training, while almost all combat sorties were flown in Hurricanes. It was during this period, specifically on September 18th, that the Whirlwinds had their first encounter with the enemy. A pair of these aircraft spotted a Ju-88 bomber during a training flight over the Firth of Forth. However, before the British could get within attack range, the German plane vanished into the clouds. The pilots and mechanics gradually got used to the new fighters, and by the spring of 1941, Westland had ironed out the aircraft's technical issues. Mock dogfights against the Spitfire and Hurricane gave the pilots even more confidence. In terms of maneuverability, the Whirlwind was barely inferior to the Spitfire, and at low altitudes, it could even outrun it by 19 miles per hour. This speed advantage held up to an altitude of about 17,000 feet. On top of that, the twin-engine fighter offered excellent visibility and was easy to handle on a single engine, which gave the pilot some peace of mind while flying. By the fall of 1940, the Air Ministry's interest in the Whirlwind began to fade rapidly. A few factors played into this. First off, the delays in getting the aircraft into service were really taking a toll. Second, new versions of the Spitfire and Hurricane had shown up sporting British Hispano cannons, and mass production of the Bristol Beaufighter fighter had kicked off. Because of that, the Whirlwind's firepower wasn't exactly unique anymore. And third, Rolls-Royce finally gave up on refining the Peregrine engine, deciding to prioritize the Merlin instead. Ironically, the Whirlwind's own perfection played a cruel trick on it. William Petter and his team had designed an aircraft with such a tight layout that making any changes to the design was either flat out impossible or just incredibly difficult. Weighing all these factors, the Air Ministry decided not to bother with further upgrades for the model and slashed the order from 400 down to 112 aircraft. Eventually, in November 1940, No. 263 Squadron was declared operational and turned in their Hurricanes. In December, the unit was transferred to Exeter in Devon, where on December 3rd, the Whirlwinds flew their very first combat patrol. Squadron leader John Munro took over from Harry Eales as the squadron commander. By that time, the Battle of Britain was already over and German air activity was pretty low, so the fighters mostly spent their time hunting for German high-speed boats in the English Channel. This came as a nasty surprise for the Kriegsmarine and forced the Germans to run their operations mainly at night. Then came 1941. Snow-covered airfields caused some serious headaches for the Whirlwinds, which had a high landing speed. Despite a string of accidents, the flights didn't stop. These fighters opened fire on the enemy for the first time on January 12, 1941, when a pair of aircraft intercepted a German Ju-88 near the Isles of Scilly. The British scored a few hits, but the enemy disappeared into the clouds. The first confirmed victory came on 8 February 1941. Two Whirlwinds ran down and shot down a German AR-196 reconnaissance float plane. However, this victory came at a high price. The British lost one aircraft along with its pilot. To this day, it remains unknown whether the plane was brought down by the enemy gunner or if a crash occurred for another reason. In February, 263 Squadron was rebased to Cornwall. As early as 12th of March, during a raid by German HE-111 bombers, 8 Whirlwinds took damage, but the ground crews managed to repair them quickly. On 10th of April, the unit was transferred to Filton Airfield near Bristol, from where the pilots patrolled the English Channel and provided cover for maritime convoys. On 14th of June 1941, the Royal Air Force launched Operation Warhead, striking German airfields in the Cherbourg area. The Whirlwinds took an active part in this, attacking not just airfields, but any targets of opportunity. It was during one such sortie on 6th of August that perhaps the biggest dogfight involving these fighters took place. A flight of 4 British planes out to attack transport ships ran into a numerically superior group of German Bf-109 fighters. According to some reports, the Germans tried to go for a head-on attack. That was an extremely risky decision, considering each British fighter packed 4 powerful 20mm cannons. As a result of the fight, the Germans lost 3 aircraft and another was seriously damaged. All Whirlwinds returned without losses. Real combat sorties revealed 2 serious flaws in this fighter. Although the 4 20mm cannons allowed them to effectively destroy both air and ground targets, the drum magazines held only 60 rounds per gun. That supply was enough for just 10 seconds of firing time. The pilots were also unhappy with the short flight range. With full tanks of 160 gallons, the plane could only operate within a radius of 150 miles. In trying to make the aircraft as compact as possible, designer William Petter left practically no room for extra fuel storage and didn't even provide for the use of drop tanks. On top of that, the fuel system on the Whirlwind model wasn't cross-fed. This meant the right engine couldn't draw fuel from the left tanks and vice versa. This drawback became especially critical when they tried to use the aircraft as an escort fighter. On August 12, 1941, Squadron 263 sent out 14 fighters that joined the escort for 54 Blenheim bombers during a raid on power stations in the Cologne area. The group flew at low altitude over the North Sea. After crossing the coastline, the Whirlwind pilots climbed to 1,000 feet, covering the bombers from possible attacks from above, but enemy fighters never showed up. Limited fuel capacity didn't allow the fighters to escort the bombers all the way to the target, so around Antwerp they set a return course. However, on the way home, they did manage to sink a few river barges with cannon fire. Production of the aircraft continued throughout 1941 at a steady pace, 2 planes per week. By September, there were enough of them to form a second squadron, number 137, based at Charmy Down Airfield in Somerset. In the summer of 1941, the Whirlwind was tested as a night fighter variant, fitted with special equipment and exhaust flame dampers. And even though all the planes eventually received this gear, no records of their actual combat use at night have been preserved. Pilots from both squadrons attacked ships in the English Channel, hit enemy airfields, and hunted trains and other ground targets. Back in 1941, the command of Squadron 263 proposed arming the fighter with bombs, but this idea was only brought to life in July or August 1942. That's when the first aircraft was finally equipped with racks. Now it could carry 1 bomb weighing 250 or 500 pounds under each wing. This modification received the designation Mark II and the fitting nickname Whirlbomber. The fighter bombers carried out their first successful operation on September 9, 1942. 4 aircraft from 263 Squadron, loaded with 250-pound bombs, set out to attack a large transport near Cherbourg. They were covered by 2 squadrons of Spitfires. They didn't manage to find the transport, however. The so-called Whirl bombers attacked 4 German armed vessels. They sank 2 of them and heavily damaged the other 2. Production of these aircraft didn't last long. The last one, the 112th production Whirlwind, rolled off the lines at the factory in Yeovil in January 1942. In total, 114 planes were produced, including prototypes, which were built in 3 production batches. Until the very end of their combat career, Whirlwinds were used exclusively as fighter bombers. 137 Squadron was the first to retire these planes. This happened in June 1943. 263 Squadron used them until December 1943, after which they replaced them with Typhoons. Throughout the entire service period, 56 Whirlwinds served in 263 Squadron, 26 in the neighboring unit, and 32 aircraft were constantly shuffled between both units. 1 fighter was sent to the United States, but there is no record of its subsequent fate. Another plane was handed over to the Westland firm. In 1946, it received a civil designation and was used by the company for various purposes until May 1947. And so ended the story of this elegant fighter. Pilots who were lucky enough to fly it called this bird a gentleman's airplane. It was ahead of its time in many ways, but unfortunately it got held up for too long in the development stage. Because of this, the plane showed up late for the famous Battle of Britain, where its advantages could have shone the brightest. You can only imagine how effective Spitfires and Whirlwinds would have been operating as a pair during the German raids. While the former tied up the escort fighters in combat, the latter would have destroyed the enemy bombers with their powerful cannons. But time had been lost. Born to be a pure fighter, the Whirlwind spent the majority of its combat career in a ground attack role. Yet, even in this new capacity, it delivered excellent results and forever secured its place in the history of British aviation.